Good afternoon, you guys. So I'm going to do this problem for you, the 2016 AP Calculus problem number 4. It's a weird problem. You know, it's difficult to put it in one category. You have volumes of revolution, you have the mean value theorem and the average value of a function in there, and you have some related rates. Okay, you have all of this. And I recall from 2016 that a lot of students struggled with that one. Okay, but let's give it a try. So what do we have here? Let's read it. If you want to open it, of course, first go ahead, but here it is. The inside of a funnel of height 10 inches has circular cross sections as shown as in the figure above. So that means that from here all the way to the bottom right here, so from this height right here to this at the bottom right here, this is 10 inches. Okay, we have 10 inches. H is measured from the bottom right here, and H is going to be between 0 and 10, and we have a radius that is equal to 1/20 times 3 plus H squared. Okay, very good. So the first question says, find the average value of the radius of the funnel. Whenever, and I'm serious when I say whenever I see this, what is the average value of the radius? I'm thinking of this function here. The average value of a function f of x on the interval AB. Okay, this is given by the formula 1 over b minus a integral from a to b of f of x dx. Okay, and this is directly related to the mean value theorem. Okay, so this is something that is really fundamental to solving problems whenever you have the word find the average value. Okay, it's common on the AP test. You will have that extremely often. So for us here, if we want to apply this idea to this problem, we're going to have our average. It's going to be essentially calculated by having the integral of the radius, which is a function of h. Okay, therefore we're going to have dh right here. Therefore we need to find the boundaries for h, which is from h equals 0 to h equals 10. So that means that here we're going to have 10 minus 0. Okay, and so that's what we need to calculate. So let's go a little bit further. So it's going to be 1 over 10 integral from 0 to 10, and r is equal to 1/20 times 3 plus h squared dh, like that. Okay, so this was a non-calculator problem, by the way, so I'm going to take my time to do all of this. Okay, so you're going to have the 1/200 integral from 0 to 10, 3 plus h squared dh, which gives you 1/200, 3h plus h cubed over 3 between 0 and 10. And so it's going to be 1/200, 30 plus 1000 over 3. So that's going to be strange. Again, it's a non-calculator problem, so you just have to do it by hand, simplify the fraction by hand yourself, and take your time. So 30 is equal to 90 over 3, so it's going to be 1090 over 3 times 200, 600. Okay, so the average value of the radius is 1090 over 600. Okay. Obviously, we should reduce this, so 109 over 60, 109 over 60 like this, Let's just double check the work right here. The integral of 3 is 3h, the integral of h squared is x cubed over 3. So 3 times 10, 30. 30 times 3 is 90, 1090 over 600. Okay. It looks correct. So we're going to leave it at this. Okay, that's for part A. Part B now. It's behind me. Let me bring it up right here. Okay. So actually, let's read the problem first. Part B, find the volume of the funnel. Okay. So for the volume of the funnel right here, what we're going to do is we're going to consider this elementary disk right here. Okay. So we have a little disk right here whose volume is dV equal pi r square times the thickness, which is in this case in the vertical direction, so dH. Okay, and V therefore is going to be the sum of all our dVs as h goes between 0 and 10. So I'm going to rewrite this, changing colors. So you're going to have V equal the sum of all the dVs as h goes between 0 and 10, which is going to be equal to pi r square dH. And we know that r is equal to, let's look above, r is equal to 1 over 20 times 3 plus h square. So 1 over 20 times 3 plus h square dH. Okay? So now we just need to integrate this. So we're going to take the pi outside. So it's going to be pi. The 1 over 20 square will be a 400 in the denominator. And so this is going to be 3 plus h square, so 9, plus 6h square, plus h to the 4th, dH. Okay? So there is no shortcut right here. We just need to do it, you know, you guys. That's pretty much it. So we're going to have pi over 400. You're going to have 9h right here, plus the integral of h squared is h cubed over 3. So 6h cubed over 3, so 2h cubed. And 1 over 5 h to the 5th power between 0 and 10. So it's going to be pi over 400. 9 times 10, 90, plus 10 cubed is 1000, times 2 is 2000, plus, so you're going to have 10 to the 5th power, so 10 to the 5th power, divided by 5. And 10 divided by 5 right here, we know it's a 2, right? So 2 like this. So it's going to give us 20,000 plus 2,000 plus 90. So 22,090 pi over 400. I'll get rid of this 0 right here and this 0 right here. And that's going to be our answer for this part B. It's supposed to be a rectangle. There you go. All right. Done. Part C now, the last part of the problem. Let's go and read what they ask us to do. The funnel contains a liquid that is draining from the bottom. At the instant when the height of the liquid is h equal 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1.5 inch per second. So I'm going to highlight this because in this type of problems, as you know by now, the most difficult thing is not necessarily the math, but to translate the text into an algebraic notation. So the radius of the surface of the liquid is decreasing at a rate of 1.5 inch per second. So what does that mean exactly here? The radius of the surface of the liquid is decreasing at a rate. So we have the word rate, so we know it's a derivative. So it's going to be the derivative of the radius, which is a function of h, okay, as it relates to the time. Okay, how do I know as it relates to the time? It's because of it's inch per second. So per second means it's going to be time right here. Okay, and so this is going to be equal to negative 1/5 inch per second. But this is not a constant rate. It's a rate that occurs when the height of the liquid is 3 inches. So this is something that happens when h is equal to 3. Okay, so that is highlighted here translates into what I wrote in green right here. So I'm going to grab this right here, and I'm going to bring it down to part C. This is what's given to us. Okay, we know that. Now let's go back up to figure out what we are to calculate. At this instant, what is the rate of change of the height? So the change of the rate of change of the height. So what is dh over dt? Because it says with respect to time. And we want that when h is equal to 3. That is our question. Okay, then let me, since I've translated now, let me bring that down over here. Okay, very good. So the question now is, how do we do that? Well, we want dh over dt. We know dr over dh. So let's look at r. R of h is equal to 1/20 times, and the function was 3 plus h squared. 3 plus h squared. Okay, so since this function is a function where the independent variable is h, that means that the only rate of change that I can calculate directly is dr over dh, because r is a function of h. Okay, and when I look at this here, dr over dh is equal to, well, the derivative of h squared is 2h, so it's going to be 1/20 times 2h, which is h over 10. Okay, very good. But what is provided to us is dr over dt. So since we are given dr over dt, but we can only calculate dr over dh, let's use the chain rule. And so that's going to be dr over dh times dh over dt. And the beauty of it is that, as you can see here, we get a dh over dt in this. And guess what? Look up here. We know that this is what we're trying to find, right? So here's what I'm going to do. Instead of dr over dt, I'm going to write negative 1/5. Instead of dr over dh, I'm going to write h over 10. And instead of dh over dt, I'm just going to write dh over dt. So this is a beautiful result right here, because if I isolate dh over dt, so therefore dh over dt, it's going to be equal to negative 1/5 times 10 over h, which is negative 2 over h. And since we are trying to find dh over dt when h is equal to 3, we just replace h by 3, and we get negative 2 over 3. and it's going to be inch per seconds. Okay, and this is this for this problem. So what I would like you to do at this point is maybe look at the College Board solution, and more importantly than the solution, to look at the rubric. That way you can look into my work and try to grade it. That might be fun. Anyway, I hope that was helpful, and if you have any requests, let me know. Take care.